continue with our discussion on the risk and returns portion of finance, and we try and understand how are returns really distributed in this particular video. Right now, to understand that, we are supposed to now talk about a particular concept called normal distribution. So, what exactly is this normal distribution? Right? So, in finance, it is assumed that returns of any kind of stock or any kind of asset are distributed normally. Now, this is an important concept because mathematically this makes sense, but does it hold true in real world is something that has to be tested. So first, let's understand what this term normal distribution means. It's also known as a bell curve. You might have studied it in other subjects or other areas. And the idea is that almost the bulk of the population or a bulk of a sample that you're trying to evaluate for any parameter lies near the average, and it's centered around the average, right? Take, for example, a class of students, right? And just to kind of ideally look at what kind of height everyone has, let's say the height of the students is what we are looking at as a parameter, right? Now, when you look at the height of the students, there would be, let's say, an average height, and assume that the average height is somewhere around, let's say, 5 feet 7 inches, just for argument's sake, right? Now, it's natural that most of the students will fall around this region. So if I plot a point here on a curve that says this is, let's say, 5 feet 7 inches, this point, and I try and plot the number of students on. So let's plot two lines. One line is the height bit. The other line is the number of students who come here. So that's the number of students. So where do you find most of the students will be? Most of the students will probably be centered around here. So if you keep plotting the number of students, most of them will be between, let's say, 5 feet 4 inches and 5 feet 9 inches and 10 inches, right? Then some will be shorter, some students here, and then you find some other students will probably be slightly taller, around 6 feet and probably more than that. So if you were to plot a curve, the curve would probably appear something like this. It is centered around the mean, right? So the mean is where most of the observations will lie, but there are a few people who will be on the right side and a few on the left side, right? So technically, with this data, you could do some sort of a calculation of average, and you could find out what is the standard deviation, right? We can do those calculations. Standard deviation can be calculated as x minus x bar whole square, summation of this divided by n, and we take the under root of this. We can do that, right? So practically, if we do that and we try and see how does this centering around the mean work, this kind of a curve, which looks like a bell-shaped curve, is called as a normal distribution. What does it say? That most observations are around the mean, right? And some observations are away from the mean. Now, there are a couple of interesting things that come around this, and we would want to write them down and be clear about those. The first important part that comes here around this curve that you see is that this curve is symmetrical. What do we mean by symmetrical? The number of observations on the left side of the average is almost the same as the number of observations on the right side of the average, right? So one part that is important is that most of the observations are around the mean and some are away from the mean. And the second part of the observation is that the curve is symmetrical in nature or broadly symmetrical in nature, right? What does that mean? That means that effectively you have the same number of observations below the average being the same as mean. So I'll keep using the terms mean and average interchangeably. So the number of students who lie below the mean is almost the same as the number of students who lie above the mean. Now, in real life, that may or may not always hold true, but for a large sample size, in a class of 20, this may not be true, but in a class of 200, there are chances this will fall true. In a class of 2000, this will almost always be true. So as you increase the sample size, the normal distribution starts becoming more and more prominent and evident. The chances of you witnessing normal distribution are more and more evident, right? And now this normal distribution, which is a symmetrical distribution, which says that the number of entries on the left side of the mean are almost the same as the number of entries on the right side of the mean, broadly speaking, is found across the length and breadth of the world. There are a lot of things which follow normal distribution: height of students, weight of students, average speed of cars on a highway. You'll find that almost a lot of these segments would follow this. Now, in finance, we assume that returns of a stock, remember, not prices, returns of a stock. So if the price is 100 on one day, 102 on the next day, 103 on the next day, these prices is not what we are considering. We are considering the return, which is 2% on the first day, correct? And then approximately 1% on the next day. These are returns. Now, these returns are supposed to be distributed normally. So if I do a plotting of the returns in finance, the distribution will probably become symmetrical. Let's see this. So what is being said is that if you have a stock and you look at returns, and let's say this is the average return, and you look at returns for, let's say, 200 days, right? And you try and plot where the return number is. Most of the observations will fall around the mean. Then there will be some days when it will be significantly below the average return, and there will be some days where it will be significantly above the average return, right? But most of the days, this would be around the average. If you draw a plot of this, it should appear like this, right? Which is a sort of a curve that's again inverted. It's like a bell-shaped curve, and it would be symmetrical in nature. Now, remember, we are talking about returns of stocks, and we are just at this point of time putting in place the theory. We are yet to test this, right? So the theory states that this should exist. Most of the days, the return will be around the mean. The practice may tell us something else. So we'll look at trying and testing what the practice means, right? So let's first look at what happens with Nifty. What is Nifty? Nifty is the top 50 stocks in India, companies in India on the National Stock Exchange. If you take these top 50 stocks and create an index out of it, that index is called the Nifty 50 index. And there is a value of this Nifty 50 every day. So we are going to look at this value, and we are going to try and identify how many days, what is the average return, right? We can find out the return on a daily basis. How many days the return is below the average and how many days the return is above the average. For this, we're going to use 2 years of data, right? So we are using, let's find out. We are looking at Nifty index values. Where do you find it? You can find it on the website of nseindia.com. You're looking at 2 years of data. You will find the returns, and we'll find out what is the average return and what is the standard deviation of those returns. And then we test the symmetry, and we look at some other data points. So we'll try and find out what is the distribution like, right? So at this stage, we're just going to see and check if the symmetry exists, right? Then we will try